Hello. So today I would like to make uh, this little program here that uses structs and tries to do some interesting logic. Type check, at least. We'll see if later on there may be some need to do uh, code generation. So first, you'll notice that we have a type checking issue here, where the type checker on line 413 has an assertion. So just to split open and get the type checking header open. So we have actively typed identifiers and we have program globals. Here, I think we'll need to have okay. So we may need to have a map from string to, I think would be an AST, um, I think it's type pointer? Am I? Or is it? Now this is the part where I haven't worked in this code base in so long that I need to open up multiple files to see what I'm doing. Type header. User type. Struct type is a user type, but there's other user types, probably. So let's just say that these are pointers to user types, shared pointers to user types even. So that would be a std shared pointer to AST user type. We'll say this is user declared type. Types. I forget something. Is there some way to like register user types? Oh no, there's lookup. Forgot that I could just use lookup here. So let's see. So let's have a struct declaration. And then we get to auto type pointer is AST user type lookup. The type name will be the struct declaration's name. And here, the module name we can just say is the file name. Okay. So let's see what happens if I go to lookup. Cannot return null. Tell it to look up in user-made types, which is a global map. Okay, so it looks at the type. Let's say it can't find it, though. Let's suppose that it can't find the type because it could not find the type. If not type pointer, or more accurately, if type pointer happens to be null pointer, we can then say that we need to make the type. Since this is a struct declaration, we should be able to say, just order the struct made. Back to buffer 5. The struct type, the creation of the struct type. Okay. So to create the struct type, we just need to say that the type pointer is AST struct type expected 3 have 0. Well, the first thing we need to send in is the name, which we'll create by using a temporary. Then we need to send in the module name, which will just be our file name. And finally, we need to send a field type. For now, we'll empty that. Cannot be bound. Okay, well, I'll just construct the temporary there. So now I need to make the vector for the field type, which is the stud pair. I'll just steal it from here, so that would be field type, fields. Then for every, forget what's in the struct declaration. Struct declaration dot struct declaration dot fields, which is a vector of typed identifiers. Okay. So for every typed ID that we have in struct declaration dot fields, we then need to say fields dot emplace we need to take the string and the typed ID. Well, we can get the typed IDs. Let's see, typed ID dot. Oh wait, it's not. Interesting. Where? I think I know where I hid typed identifier. Typed identifiers I hid in the AST. It was the node utils. Yes, typed identifier. Name, type, and location. If it's a name, type, and location, I should just be able to emplace back typed ID dot name and typed ID dot type. I'll see if that works. Not too sure. We create this, and then we can say that we're gonna move fields in. So when we look it up, oh wait, here we should have a map to contain all of the active types at the time. So this should be something like map between string and shared pointers to AST struct types. Let's call this the active, or no, visible structs. Currently, structs can only be declared at the file level. That is, you can't have it like in C where a struct can be just randomly declared inside of a function. You have to put the struct at the file level, and it's visible for the entire file. So here we could instead say that if visible structs dot contains, or no, we want, yeah. No member contains. If we say dot find, if we try to find for the struct declaration name, and it happens to be visible structs dot end, print error with an optional location. and the location will be the struct declaration dot location. We'll say here struct name has been previously declared yeah, I'll just say that. It has been previously declared. And then elsewise, we just get to say that the visible structs shall then place in the name, so the struct declaration name, alongside the type pointer that we just got. And here we'll just say that we move this guy. Now if we order the construction, interesting. I'll have to see this outside. So for a ninja, well, okay, of course. Welcome to C++. Error, no initialization for the pair of const string and const shared pointer. Why? Why must you do this to me? And place here. I see why, because this is a reference and this is not a reference. Because this would expect to do a copy, and this is not a copy. Yeah, here we cannot construct this from the second argument because one's a struct type and one's a user type. Ah, right. Introduce specialization at this point. We need to say stood dynamic pointer cast to an AST struct type auto struct type pointer is this type pointer, and then instead of moving this, we will just move the struct type pointer. And at this point, we will also assert that the struct type pointer does not equal null pointer. Why should it not be null pointer at this point? Well, if it was null pointer, we would have done this logic here. So the only way it's not that this assertion fails is somehow user type lookup would return us that. So we'd have to say here, and so user type lookup somehow returned a non-struct user declared type. There. And then if I ninja that, well, that runs. Let's see, does it work when we do this? Struct my type has been previously declared. At line 1, character 0, it says that it's been previously declared. Why? Why would it claim that? Wait, no, this is wrong. We want it if it does not equal the end. There. I forgot how C++ containers work. It's a minor detail in the language, of course. The identifier has not yet been assigned a type. Correct. Has not been assigned a type. Okay. That's interesting. Let me see, what is AST? This would be user type. This would be user val. It's an expression node, definitely. User val. How is the struct parsed? 'Cause we never get to that. We do have a test for that, right? New parser test would be struct declaration. Yes, we parse struct declarations, parse the unit function, parse a struct initialization. Let me just run the test just to be sure. That's a Ninja. I want to do Ninja test. Okay, so it should be fine. But why would it return a user value? Let's see. We have struct initialization? We should. Yeah, struct init. That's a thing. So are we never making a struct initializing type? Let me just read the test to be sure. This is why we write tests, so that if something gets really strange in the code, we can just read the test to figure out what's happening. So we have this guy here, my struct type, which should have a struct initialization on it, yes. Wait, is it because the type checker doesn't have a struct in it? That's entirely possible. Okay. So now I've learned. And so here we need to add void type checker visit over the AST struct init, AST struct initialization, because this is a visitor pattern. And we will assert false here just to get something through. And then to open up the visitor for the visitor, we need to open up the type checking visitor header. And where is... Ah. I forget that we have these expanded nodes that need to be worked on. Okay. And we never added struct initialization. Well, we need to add that. Let me just write a commit quickly. I think I've got some commit that could be written here quickly. No, I don't want that. Oh, that would be so close. Edit this patch. Yeah, we'll need visible structs, but I'll also want to do a format on that. Slash, and I want to run a tools format immediately followed by this parse. Stage this hunk. Nope. Do not stage this hunk either. Do stage this hunk. Immediately followed by property. Okay. Register user declared structs in the type checker. And there we go. Now we get to rebuild everything because I changed the single header file. Of course, undefined reference to the code generators and printers version. Okay. So because I added that into the unroll set, I need to add that also into the code generators CPP. Struct declaration. So this will call a struct init. Assert false. So effectively an unreachable. Then we'll also say that we need to go to the printer. And here I can just paste this down. And then this is the init. This is the init. And then here, the initialization name, initializations fields. What did I call this? Let's see. Struct init initializers. Every auto ref init in the initializers. It's pair. And so here it's a vector pair, so I get to do an immediate destruction, and we'll call this the name followed by the expression or the value. And here we get to say that there is to see out that the name is equal to the recursion of the value. So that would be, how do we recurse again? We say that the value should accept the dereference of this. I think that should be fine. Everything will compile, and then I'll just write up a new commit. Yeah, nothing too special. Expand node map. Now we get to do type checking. So let's see. If we build out this guy, identifier has not yet been assigned a type. Hang on. Has not yet been assigned a type. Is it thinking? Help. Okay. I want to see this, but I want to AST it. Well, there's a lot worse things than I thought. Let me just read the example again to be sure. Ah! There's my problem. Should be called lol. There we go. I'll fix that later, but for right now, the identifier lol has not been assigned a type. That makes sense. You see, you have to also double check your tests. You can't just let them. You can't just write the test the first time and hope it's correct. Why has it not been assigned a type? It should have been assigned a type when we entered the function. So func call. Func call. No, I don't want function calls. I want function declarations. There. Okay, this is a bit of a long function, but let's read it. So we get the name. We try to figure out if the function's already been typed. So if the type of the function is not null, that means we've already been defined and we should fail. The same logic may be present in the CodeGen module. Then we take addresses, we do an extra logic. If the current return type is null, there's an unknown return type. We then take in the arguments, we push back types, function type, we bind the type, we add in some type actively scoped identifiers, we then bind the type for every argument. Does bind type do anything? Should not do. Actively typed identifiers, add to current scope, move the identifier, move the type. Function declaration. Func type, func declaration. Okay, but when we go here, find the parameter types. The parameter count, argument at I. That does return the type pointer. We should assert that the type is not null. There we go. Here, we should assert that the function type, when we get it at I, does not equal null pointer. If there is no pointer, then we're saying we don't know the type of this parameter, which is possible. Let's see, now if I build that up. Aha! Found it. There it is. 02. So, the problem here is that we're binding the type a bit too early, I think. These types here are type pointers. They come from parameter type. Wait, we should assert here that param.type is not equal null pointer. So if it is, then we have a problem. $290, yep, that moved the value. That moved it up. So here, we have a problem. How could the parameter be null? Well, if the parameter is null, I think I know why. Let me see. Because we set up the types in the parser. And, well, we call it the new parser. I should probably change that. There's a lot of refactoring to be done soon, which may end up being on Twitch and live streamed instead of that. Parse typed identifier. Parsing a typed identifier. So we get the colon, the second type, parse type. User type lookup. Aha! Here's the problem. This lookup here for user type doesn't know about the struct currently, because when we parse the struct, it'll never look. So let's see, what if I were to go to struct declaration, right? And then I would need to be able to paste this down here and not return it. Let's say auto type putter is this. And all we have to do is assert that the type pointer is not equal null pointer. Or no, we need to create it here. That's the thing. AST struct type create. You take a string. Well, that can just be stood string temporary of name.text. The module name, which is that file name here still? Now I'm confused. Do we... Okay. Mark A. Lex module name. Okay. We can name it different, of course. And the fields that we have found. Here they're... Right, here they're top identifiers. So I want this. All I'll have to do is just assert that this is not equal to null. Vector fields. There. This will be AST struct type field type. Ah, here's the problem. This is for fields, so we need to say that this is actually what we called, how to say it, these will be struct fields. Auto ref typed ID in fields. And here we'll have to do struct fields dot place back typed ID dot name followed by typed ID dot type. And here we should move so that we don't cause additional ref counts. Moving a temporary object prevents copy collision. Hey, look at that. Compiler, thank you, Clang D for being too intelligent. And place back is called in a loop. Consider pre-allocation. I shall. Thank you for considering the pre-allocation for me. This is considered. Build it up. Okay. So here we need to say, I'll just make a comment here. Insert the new struct type into the AST type system. Type registry. Ninja time. And now we get to build this, and we still have that assertion. Interesting, interesting. New parser CPP. Should get to here. You know, that assertion doesn't fail. Parsing an optionally typed identifier. Parse type. Let's just save this here. So we'll have a type pointer. Fall through. We will assert that, so before we return, the only thing we want to really do is assert that the type pointer is non-null. Return type pointer. Which we can now just check here. Right. So that means we now get to go to the parser and figure out why it decides that we should not have any cool things like that. Okay. Let's do some debug printing. So struct decal. Registered struct name.text at name.location. There. And that should work. So what happens if we do this? We registered a struct, and then it didn't work. Okay. So when we do this lookup call, what's happening? Turn user mean types.lookup. Right. Name, module name. I think we have the order around correct. Do we? When we create a struct type, we do add it to user-made types. So here's the so the module comes first, then the ID, then the value. Okay. So here, the module comes first, then the name. The module comes first, then the name. Here it's name, then module, and here it's name, then module. Okay. So if we go up another level, this should be name, then module, and then our struct vehicle is name, then module. Interesting. Registered a struct called myType at that level. Let's say looking for arrow peak token text. Okay. Looking for myType. Interesting. The module name's not different. It can't be different. In module Huh. That's really interesting. This can't be a null because we've done that. We're not redeclaring, otherwise that assertion would have been hit. When we add, do we add anything correct? Globals find the module. When we find the module, if the module is at the end, return null pointer. Makes sense. Otherwise, we find the items iterator. If the items iterator is not at the end, we want to return the item iterators second. Otherwise, we return null pointer. Right? When we add, emplace Is this fancy emplace wrong? Let me just go read the reference here. We want to pull up map. Yikes. Map Right. What M place? Okay. I think I'm safe. M place the ID and then we... No, that's not gonna really work. Let's see, what if... Would this not equal the second end? Let's see if I can load this up in GDB. Okay, we read symbols for it. We break at source, new parser, CVP, line 450. Breakpoint 1 is pending, and I want to run this with examples struct.lil, enable debug info, I think if I go to frame 6, yep, frame, print out what variables are in scope here. Print out this. Real debugging today. Real debugging. Adding struct in mod. Looking for struct time. Adding struct. There's my problem. Adding struct name. Let's go up here. Let's assert that name, that the name is non-empty. And we'll also assert that the module name is not empty. Oh, that's a really weird bug to run into, because you'd never think that these things are empty, but they are. Well, actually, no, wait. Could the empty module name be useful for something? As like a built-in. I'll write a to-do here. Well, I could just not write the assert, and then the empty module could mean... Well, no. When you create something, you will have to have the non-empty to-do, the empty module, the module, the module, may be useful. Well, it's a strange error you'd never expect. Hmm? So it's not empty here. Aha! Look at how silly I am. I don't even know how to do move semantics correctly. I've got stood move of a name. I've got stood move of name, and immediately after it, I use the name. Oh, funny me. Well, that's an internal bug that's been lingering there for some time. Error, X has not been assigned a type. Well, to prevent that in the future, I will now go to the global map, and I'll tell the global map here that problem is here that the keys are not necessarily strings. Oh, and this is also a string. Huh. Well, that's a bug. Oh, I can if context for this, can I? Yeah, I think I can if context for this. If const expr is same type. So if the key type is the same type as stood string, then I will want to assert not id.empty. Yeah, there. So there's no way that the so now we make that just to see what happens. So for right now, I'm going to do a bit of cleanup just to see. So I can do git store-p on the source. No, that assert's gonna be good. Well, no, that assert's good. These asserts are good. This is good. This is good. I do want to No, I don't think we need to discard that from here. I don't want to discard that. That I won't discard, I'll clean up. These I won't discard because they're... Okay. Let's add git commit source, the global map. Let's do that. Uh, The global map prevents empty string as a key. Yep. Now if we do a diff on this, type CPP, empty string is not a valid type name. Let's call this patch pernicious bug regarding inappropriate student move. I could amend that commit, but no, I'll be fine with that patch. So if I diff this now, it's got a new parser. $450, all right. I don't want that anymore. So let's see what happens if I do this. X has not yet been assigned a type. Assigned a type yet. Oh, because this is a binary expr, I think now. Do I have a test to show that it's a binary expr? Split test new parser. That's a constant declaration. Parse binary expressions. Parse function calls. We'll parse member access. Yeah, so we should be parsing this as a member access. Okay. Left-hand side, right-hand side type. Problem is that here there's a context that we're in because the right-hand, this is different because the right-hand side of the binary expression is, there's a short circuiting operation here because there's a context. So we say if left-hand side type dot, there's a way to write this sort of stuff. We don't want to own it. We just want to say auto star struct type is stood dynamic cast to an AST struct type if the struct type does not equal null pointer, has to be a star. And here we have to say dot get. I'll read that later. So let's say we do have a struct type, right? Oh, it's not std dynamic has, it's just dynamic has. What am I thinking? Okay. So here we have a dynamic has, right? So we got our struct type, and now we have to get the left-hand side is the right-hand side has to be exclusively in this. So we will now assert if right-hand side is dynamic has to, this would be a user val, I think they would parse it as. And it would be binary expression dot right-hand side, 8 pointers, and if the right-hand side is null pointer, it does not equal null pointer, we get to do some cool logic. Else print error, and we're going to print the error at binary expression dot location. And we will say things like expected an identifier to the right-hand side of a dot found. We will say that we found dot right-hand side. Set braces for readability. There we go. Found the right-hand side, and we get that out there. Okay. So when we do find the right-hand side, so in here, what we know at this point is that we have a struct on the right, on the left. So we'll say something that we have struct dot ID. So when you have struct dot ID, we now get to look inside that struct. Struct type arrow field type. Auto field iter. Std find if. Oh wait, no, we can't do that. We have to manually do this. Oh. Auto I starts off at 0. 0 U probably. I is less than struct type arrow. What is it? A field count. Should both be constant because we're not really going to modify them at all. Auto ref field is struct type field at I. Auto field can be declared as const, so we have field if field dot, wait, what is field? basic pair between string and that. Okay, so dot first exactly equals right hand side arrow ID. So user val. We need to assert that its value type is identifier. Not null pointer, and right hand side arrow val type is value type identifier. Look at that. It was so smart and nice of it. Equals val. We can turn how did I forget how did I return values here? Get value store result. Yeah. From store result of the type pointer and the expression we're storing it to. Type pointer, which is saying something like field dot second, and the expression we're storing this onto, which is the binary expression we got. Well, look at this. Right, expressions can't be printed. Can they? Yeah, so there's a lot of errors here because for this function, type checker CPP line, this line here. So we're trying to print the expression. Oh no, I know how to do this. We say arrow val, which is not necessarily the case. If right hand side is not null pointer, you can just do that. Here we'll say found strange actually no, here we'll just assert false. There's no way we should get here. Yeah, I'll fix that later. Well, we got past struct declarations. Huh. I'm just gonna write a commit then. Actually, no, there's something I need to fix there. And here, turn, print error, find expert dot location. Could not find a field named RHS arrow val in struct type there we go. There. Okay, that gets us that far. If I commit everything, type check struct declarations and field accesses and member accesses. So now I need to do struct initializations. Line 465. Struct init. Well, the first thing we should get is the struct declaration, which would be the same thing as saying AST user type lookup the type name, which we know to be struct init, and the module name, which we will just say is file name. No conversion from this. Dot name. Ta-da. Then here, if actually wait, there's a way to do this. Dynamic pointer cast this whole thing to a AST struct type. That was very, look at that, that's really easy. We can just, immediately upon lookup, we can just tell it to dynamic cast. And we can say here that if the struct declaration is null pointer at this point, we can say We'll return print error, and the location will be here. Struct init location. Friends, and here we get to say that single character struct init name does not name a struct, a defined struct. There. So now that we know that it's not null, we can now do some work. So to do type checking, we would first say things like actually, we'll return at the very end the store value of struct decl. Store result onto this node, struct init. Right? In fact, we'll order it moved here. So very interesting. But now that we've ordered it moved, we have to do all the logic here. So we have to say check each field for correct type. So the way to do that is to say for every single I starting at 0u, I is less than struct init dot. Wait, no, it doesn't. No, struct decl is the one that has this problem. Less than field count plus plus I. Yeah. Then once that's done, so we're going to walk through every field here. And then we get to say auto target type is the struct declaration is whatever the target is whatever the declaration tells us the target. So here wait, doesn't target type not tell me the field? Right, it tells me the pair of things. Which is a problem. But I can just say ref name target type. Unused names. Step 1. We now need to go tell the initializer that it has a name. Auto iter is stood find if from struct init dot initializers dot begin to struct init dot initializers dot end bool by reference capture name by auto ref initializer return whether initializer dot first is the same as name. Reference to local binding declared in the enclosing function. Huh? Eh. Okay. If iter exactly equals the struct init dot initializers dot end, return print error. First, we need to send in the location, which we'll say is struct init location, missing initializer for name. Type so now that we know the iterator is not null, that means we have the type. Auto so it's the real type get value of iter arrow second. Type context is this. Well, if they say they want the reference, we can just deref both of those sides. That's dereferenced. Oh wait, it's not a pointer, the actual thing. Okay. If target type does not equal the real type, return print error of iter arrow second arrow location. Expected an expression of type target type. Found one of real type. That hopefully will work. For field name. Narrow name and capture name does not necessarily enable references to a local binding. Hmm. Okay. Let's do some shadowing. Auto name is string name. Kind of simple. Actually, no. Let's call this the field. name, which is actually equal to field dot, no, field dot first. Okay, so what I'm doing right now is I'm breaking up the structured the structured binding that I thought would be very cool. And I'm breaking that up into two variable declarations. Apparently you can't use structured bindings. You can't lambda capture structured bindings, so I'm just using that. Let's see. If we do the run, identifier of type true has not been assigned a type. Where did I use true in this? Aha! There it is. True is not assigned a type. Strange. Okay. Let me just check my tests for the new vector. Huh. Is the Lexer supposed to tell the difference between booleans and not, or is it just not caring? It's been some time since I looked in here. Next token, moment, is alpha, return next identifier. Right, so true could be a reserved word at this point. Do we have token types for true and false? Symbols. Hmm. Well, let's say the Lexer doesn't care about that. Does the parser care about true, false? Well, no. But when we do token text, parse atom, if it's a boolean, it's a boolean. Right, we never parsed that, huh? I probably should write a test for this. Okay, let's go to the new Lexer. Can't ignore comments. We'll parse hexadecimal. Wait, we said we'll parse hexadecimals? There's a plain string, a string with escape characters. We'll parse integer, we'll parse hexadecimal. Let's just copy this and we'll say we'll parse booleans. Parse booleans, boolean literals. True. Next token. I want to assert that this is a boolean and that its value is just true. You know what, I'll do the thing where I add an extra space here just to see. The next token should be eoff. Actually, no, the next token after a new line is going to be false. False. So here, that, it's also boolean false. Okay, but if I run the tests, this should fail. Yeah, the Lexer test failed. Excellent. This is what we want to do. We want to see test-driven development. So now, we need to find out how to make it not fail. Well, this would be an identifier currently. This may be bad on performance. Okay, primitive types, keywords, literal values. True. Token type, boolean. Paste. And here we get to say that this is false. Yep. So we get to just work over that, yeah. If we find it, we get to move it out. Otherwise, we get to do that. Yay. So now we get to write a commit here. We do want, oh wait, Q. The new Lexer should 140. Yeah, I want that. I want the extra comma at the end. It should still be the same, but now when I do a git commit, it's fewer lines to diff over. Yes, I want to stage this hunk. No, I don't want to stage that one. Yes, I do want to stage this one. Add true and false as boolean literals. There we go. I ninja that, and then I run this. Error. Argument expects my type. Found my type. Interesting. This is in the type checker. Argument. Argument 1 expects type found. Okay. So what's happening here is the expected is not the actual in the function call that we have. What function call do we have? Well, let's see. If we do struct.little make result lol. This apparently is wrong. Why though? My type that. Is it an equality thing? actual is null pointer, and the expected is not some pointer type. Alright, this is a shared pointer now, right? So this shared pointer somehow does not equal this other shared pointer. I'm going to check on what shared pointer equality means. So, shared pointer. If we were to do shared pointer, and I were to ask for your equality operator, the equality operator can operate on any two types, T and U, compares the two, or compares the two, compares them with a null pointer. Note the two comparison operators similarly compare pointer values, actual objects passed that are not compared. Aha! Let's try dereferencing those. Then. Binary expression. Invalid operands. An AST type cannot be compared with an AST type. True, an AST type cannot be compared with an AST type. Let's see, if I just pick out the raw pointers. Why would the raw pointers disagree? Well, this disagrees because it's a type pointer. Type pointers would... Let's see, when we construct this, we create this guy. This one. Old type. If the old type is not that, we're saying we redeclare, but we're never redeclaring. We create this pointer. User made types add. And then lookup here returns user made types lookup. Okay. Function call it arg_i. Examples. Little, which we know this to be a name. Find the type of. When we find the type of a thing, we walk backwards through the actively typed identifiers. $270. GDB up break at // source visitor type checker.cpp line 270. Load that up, and then I want to run this on examples struct.little. Enable that for this session. I probably should set that in my global init up. Inferior exited. Thought I sent a breakpoint. Huh. Well, let's just assert false. GDB's ability to do this stuff. So ninja. Then GDB, and then run with our examples. Backtrace. Then we want to fall back to frame 6. And I want to print the expected. RTTI is not found for this class. Also want to print the, was it the actual? They're different. Why though? Why are these two different? Because one comes from up here, and one comes from down here. Let's see. If we were to, this is some real debugging time. So if we were to open up the type CPP, and we were to make sure that the structs were never created twice, so creating name, aha! We create it twice. Why do we create it twice though? User made types. Why would we make it twice? That's interesting. Why would we make it twice? This is the part where user made type probably needs to be refactored, so I can't just randomly access it. Let's go for void dump. Post tree. Left-hand side, add a const. Const global map of key type and value type ref for the right hand side. Sys types not needed. every mod name, then contents in globals, and valid use of a non-static, well, right inside dot globals. I think what I need to do is I need to say that this should only work if, yeah. So maybe we should like enable if this stuff. Or no, there's constraints, but yeah, for right now I'm not going to be too worried about it. Ref name item in contents. So let's see if we do that, we then get this guy here. Then can say here that for every item, we'll just do left-hand side name, immediately followed by a colon, immediately followed by the item, and then immediately followed by a single comma. I'm fine with trailing commas. I'm not too picky about it all. So that happened. Okay. So there's our printing. So now in here, let's see, that should just apply everything. Okay. Ah! Oh, this is bad. So this one has the full name, this one has the short name. Oh no. Which one has the short name, which one has the full name? Name. I knew this would come to bite me. In module name. Get to load that up again. Decisions, they come back to haunt me. Decisions, they come back to haunt me. So the first one is the full file, right, because we steal that out of the lexer. Then here, we normalize it down to just the file name. Okay. Well, time to standardize. Is it the file name, or is it that? I think we should try to pass the full name. I think I do that in program CPP. When I do type check, when I order a type check, that's in the program globals, file name resolve relative to the project root. Why do I do that? Why do I resolve it relative to the project root? Shouldn't I also do that for... Well, what does the lexer do? Or at least the... when we go in main, Elements here. From file name. Lexer from file name. Right, so we use the lexer, we tell it to open the file, and then... Wait, the lexer knows nothing of the project root. Right, because where's the project root? Project root's something the program knows. Huh. This gets tricky. There's disagreements in here. We have two options. Either we standardize behind absolute paths, or we standardize behind relative paths. I'm going to standardize behind absolute paths until such time as and still I can figure it out. Normalized absolute, normalized absolute, normalized absolute. So the modules will be stored by normalized absolute, but let's see. std file system relative. Note currently AST imports are not updated with absolute paths, but the AST file names are absolute paths. That's why we have that distinction, because here, right, here's the problem. Project root. Parsers need to know about the project root now, because they need to know about the types. Oh. Yeah, this gets into some tricky territory. Well, computing the project root. Load modules. Project root is already here. It's just that when we order the read module, which I think is the file we want, yeah. When we order read module, we just pass the absolute file name. We don't pass the project root. We already have the information though, so let's just pass the project root along. Module. Well, here we can just take in the std file system path reference project root. Unused. Well, the parser needs to know the project root. Const. Okay. So the parser now knows about the project root. Wait, inform me on something? Does the parser need to be able to be copied? Because it shouldn't really need to be copied. Shouldn't really need to copy it at all. Non-movable, non-copyable. Great. Ref. Right root. Path reference project root. No, it needs to be an optional project root. Yeah, because it may or may not. Yeah, I'll drop that. I'll drop that. And we'll store a std optional. Let's have an internal thing for proper module name. So right now, and we're giving, I feel that there's a separation of responsibilities issue here. Separation of responsibilities? Is issue? No discard attribute of stood string module name. This should be const. Then based on whether we have if project root, so if project root dot has value, return project root dot arrow. What was the function call we used here? I'm going to go into program. F1. Turn std file system relative from the module file name. The module file name is stored in lex arrow module name. And then, yeah, that's another thing. Module name is not really module name. Project root. That. Oh. There's a redeclaration. Look at that. Which reminds me that the lexer, new lexer, HPP, should not return module name, it should return file underscore name. New parser HPP 116. Just to be absolutely clear that this is actually a file name. Okay. Dash P. Nope. 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 Yup. Nope. 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 Rename. Lexer. module name to file name. Nope. 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 This I'll take. This I will take. This I will take. Will take. Will take. Will take. Will take. Will take. Will not take. Parser now knows what module it's parsing. So now that we're redeclaring in source AST type CPP plus 67, it's not a redeclaration anymore, actually. It's reuse. So we can return the old type. No vial will return. Dynamic pointer cast. Well, here we can just say std dynamic pointer cast to a struct type. Actually, no, we have to do two separate things. We have to say that old type, close on that, right? So we say old type, auto possible struct is this. Then if possible struct does not equal null pointer, we can return it. Else we need to see error. Oh, actually, no, let's say see out. Type name is already registered in module name as a non-struct type, but struct type P and L, and assert false. Lovely. Error cannot find value X. Well, that's a different error. I'll make a commit on this. Actually, no, I could have committed that. I just needed to split it. Split this? Yes, I do want to do that. No, I don't want to do that. No, I don't want to do that. No, I don't want to do any of that. Permit type reuse. Let struct type be reused. There. Could not find value x. I want to rip grep could not. Well, the only place we say could not find value is CodeGen. Huh. I've been going at this for 2 hours, and I've gotten to CodeGen. Yeah, I'll leave that for later. Maybe I'll do it off stream. So, thank you everyone for joining me. Sorry I didn't say hello, but I had to get straight into the code.